So now we're going to consider a system, a non-homogeneous system of equations, and we're going to try and solve it using our augmented matrix. Now, in order to do this, we are going to use our, sorry. In order to do this, we start by constructing the augmented matrix and then perform raw operations. Now, here we've got lots of space to construct the matrix, but I'm just going to construct it right near the top. And we take the constants from each term. So 1, 1, 1. We put a vertical line, and then our coefficients go here, and then our constants go behind the line. Coefficients are the numbers multiplied by our variables, x, y, and z. Constants are the values after the equal sign. So we get 2, 3, 2, 7, 3, 5, 3, 10. Okay. So that's our augmented matrix that represents this system of equations. Remember, augmented matrices represent systems of equations. Now we're going to, in part B, it says use elementary row operations to solve for the echelon form of this matrix, list the free variables and basic variables. So here, this is basically apply the elimination algorithm until you get to echelon form. I'm going to start with zeroing out these two entries. So I find my pivot, which is here, make it 1. It's 1, put it in the right spot. It's in the right spot. Okay, now 0 at the column. So R2 minus 2R1 replacing R2, and R3 minus 3R1 replacing R3 gives the matrix. The first row doesn't get touched. 4, second row becomes 0, 1, 0, minus 1. The third one becomes 0, 2, 0, and then this becomes 10 minus 8, sorry, 7 minus 8 is minus 1, and then this is 10 minus 12, which is minus 2. Okay. Now we've zeroed out the column. We go to our next pivot, which is here 1. Put it in the right spot. Make it 1. It is 1. Put it in the right spot. It is in the right spot. Zero out the column. So we're going to take R1 minus R2 replacing R1, and R3 minus 2R2 replacing R3. And this gives us 1, 0, 1, 5, 0, 1, 0, minus 1, 0, 0, 0, 0. And this is really nice because we have this row of zeros. We know that we are finished, and we don't have inconsistency. So whenever we have all zeros, we go, is there an inconsistency here? If this is a non-zero number with all zeros, it would be inconsistent, but it's all zeros with a 0. And now if we look at this matrix, first non-zero entry is a 1. That column zeroed out. The next row, it's to the right. First non-zero is a 1, column 0 out. Next non-zero is to the right. Well, there's no entries, and then this last one has no non-zero. So yes, we are in echelon form. So we have done our row operations, and we've gotten our matrix to echelon form. Okay. Now that we're in echelon form, this represents the system of equations. X plus z equals 5, y equals minus 1, and 0x plus 0y plus 0z equals 0. And here, our pivot entries, or these first non-zero entries, they represent our basic variables. So our basic variables are x and y. And every other variable is a free variable. So our free variable here is z. So we have the basic variables x and y, and we have our free variable z. Okay. Now we need to solve for the set of solutions. Now, here, when we're in this augmented or this the echelon form for our system of equations, there were two methods we talked about. Okay. The first method is similar to solving homogeneous. And our second method is solve for a solution and solve homogeneous system. Okay. Now we're going to start by solving this using what was similar to our homogeneous. We're going to let z equal s, which is an element of the reals. Then x equals 5 minus s. And let's change this s to a t so I don't confuse my 5s and my s's. So 5 minus t and y equals -1. And if we actually, let's start this over and remember what our process is. So let x, y, z be a generic solution vector. Let z equal t, an element of and here, what's our field? Let's scroll up. We're not told, so it's just an element of the field. Okay. Then, now that we've let our free variables be free, we can rewrite x in terms of those free variables. X equals 5 minus t, y equals -1. Updating the solution vector gives 5 minus t -1t, which equals 5 -1 0 plus -t 0 t, which equals 5 -1 0 plus t -1 0 1. So our solution set equals the set containing 5 -1 0 plus the span of -1 0 1. We take all the vectors corresponding to our free variables and build a span using them. So it's the span of the set containing -1 0 1. So we use those vectors to create our span, and this constant vectors that we have is on its own as well, and we take the sum of those sets. That allows these free variables to be whatever we want. Now, some people find this technique the most straightforward. They just do what they did before. Now, instead of just having constants time vectors, they have a single vector with just numbers plus constant time vectors, and then they build a span and add it to the set containing that single vector. The other technique we could do is we could consider the system x plus z equals 0, y equals 0, 0, x plus 0, y plus 0, z equals 0. And we could solve for SH. Okay. And now when we're solving for SH, we consider X, Y, Z, let H or Z equal T, an element of the reals, then X equals minus T, Y equals 0, updating X, Y, Z gives minus T, 0, T, which equals T minus 1, 0, 1. So SH equals the span of the set minus 1, 0, 1. Now solve for XP. Now, when solving for a particular solution, we can let Z be whatever we want. Z's a free variable, but when we're solving for a particular solution, we just let our free variables, we can pick whatever we want for our free variables, and that allows us to pick a generic solution. So we're going to pick 0 because it's easiest. Could pick anything, but we're going to pick 0. Okay. And we're going to consider the system X plus Z equals 5, Y equals minus 1, X plus 0, Y plus 0, Z equals 0. And now let Z equal 0, then X equals 5 and Y equals minus 1. Thus, XP equals the set, or equals the vector 5, minus 1, 0. Okay. Therefore, our solution set is, and the solution set is going to be XP plus SH, which is the set containing 5, minus 1, 0, plus the span of the set minus 1, 0, 1. And you'll notice that this solution set here is the exact same of the solution set we had up here. Okay. Here we split it up into two ideas, the homogeneous portion and the particular portion. And here we did it all at the same time. Both work. What you'll find as you study higher and higher mathematics is that there's a lot of places where we do this technique of 1, homogeneous, 2, particular. Okay, and that's why we wanted to set up this. You could do it this way. You could do the homogeneous, then the particular, but you also could do it just by letting the free variables be free, isolating, and getting your solution.